Welcome everyone. Methods of total quality management is what will be the discussions today in this presentation. Introductions. What are methods? What are the various methods? There are two kinds of methods. One is the data generated by the process. As when you start working about it, what are the data that comes around it? And then there is something called a data-driven methodology. It is all about pointers and processes that comes around it. Look out here is the statistical interpretation wherein the fluctuation of the production goes around here, and probably we are benchmarking. So there is something called seasonal variation and probably new technology. Now, how does this data been replicated as in this graph has been generated? Obviously, yes, as in what all machine has been produced, what all vendors has been consuming, the data points that has been generated out here, it has been plotted onto the graph. And that is how we come across data driven methodology or data enabled processes thereby. There are simple seven tools altogether. We are talking about flowcharts. We are talking about Ishikawa, the fishbone diagram, which states for every reasons, what are the reasons for a particular outcomes altogether. So cause and effect. There are check sheets, there are Pareto charts, histograms, run charts or control charts, and the scattered plots correlation analysis thereof. These are the tools that are very much required for you to understand the quality management. The seven simple tools. It's flowchart, the Ishikawa diagrams, the check sheets, the Pareto charts, the histogram, the run charts, and control charts, scattered plots, correlations analysis. We'll discuss each one of them, right? So here we go with flowchart. Remember the system theory. System theory is what comes in and what goes out. In between is the processes that comes around it. So we are talking about input, output, the suppliers and their interactions thereof. So it's divided into a complex process into much simpler sub processes. It is all about the flowchart. Flowchart reminds me of a pictographical representation of the workflow altogether, as in who is doing what all departments are involved into it, and if there are any bottlenecks, it becomes very easy for you to understand the bottlenecks there through the help of a flowchart. Let us give you an example of a patient transport process that comes around in a hospital where the doctor determines the need for a x-ray of the patients. Now the request has been made, they have been logged and prioritized, and I believe there are n numbers of doctors and n numbers of requests have been made to the uh, team. So information is to be taken, logged in, and as per the priorities should be set across, and thereby we need to have a dispatch transport. The information has to be passed on, percolated when the patient has to report, what has to be done, where the equipment is free, and take the patient for X-ray. The transporter arrives and the patient is transferred from the hospital beds, taken for an X-ray and returned back. This is a simple one of the smallest of all processes in the hospital that has been generated through a flow chart. So types of flow chart can be layout flow chart. For example, how there's a movement of goods, there's a movement of staff, and then there are a data flow chart. That is probably how information is being passed or processed. So one is the layout flow chart, example of movement of goods or a staff, and data flow chart, which is example of the movement of the data or information uh, from one point to another point. For example, the example which has been given is a leave approval process thereby. Ishikawa diagram, also known as fish and bone diagram. It's like your fish bone that has been going around it, which tells you about what are the causes and what are the effects about the process that has been entangled. Non-quantitative tools, it is qualitative, sometimes called the 5M diagram. Why 5M? Because it starts with men, machine, material, measurements, and methods. This is what we are looking forward to. Again, I repeat, men, machine, materials, measurements, and method. That is why Ishikawa diagram would always tell to you, there it comes. If you look into it, we have men, material, machine, and methods, along with the sixth diagram, which can be environment. Environment can change. You know, we had this epidemic of late of COVID-19. So it was about an environment, no fault of the organization, but things goes wrong the way you want to put it across. Central tool for quality assurance programs, specifically useful for operational procedures, could be derived from the flowchart per se and the first diagram that has been given out there. So what are we doing about checklist? We are ensuring that each of the check boxes, each of the parameters, each of the steps have been fulfilled, and that is the best method for a quality assurance program specifically used for operational procedures. Could be derived from flowchart and the fishbone diagram. Example of checklist as I've been given. This is how in computers can be given on a tally. You are counting it, but manually every four verticals that we cross, and then we cross the fifth vertical altogether, so it becomes a group of five every now and then. So what are we talking about it? I'm showing you an examples in terms of equipment broken, which might be subtotal, and you look it has been notified. So people who are literate, people who are not literate, either way they can pinpoint it and count very easily. So this is how it has been done, or should I say, this is how exactly it's been done on a day-to-day world, in the real world. So four verticals and then across, four verticals and across. It's a cluster of five that we can go around it. So I need to only count the number of cross, and we'll come on to it. So if you look into it, this is 5 plus 5, 10 plus 3, 13. Or this is 1, 2, 3, that means 15 plus 2, 17. So it becomes much more easier to understand checklist. The simple example of paint job quality that we are looking into it. What are the problems? What are the bubbles? What are the runs that comes around it? Here comes the process for flow diagram. Did I say it's a movement of people? Did I say it's a movement of good? Did I say it's a movement of data per se, and how it goes around it? So look out what has happening with the head office where we are procuring, or probably raw materials is what is we are looking forward to. So we have processed fruit through two vendors, two suppliers. They are looking at receiving an intent from sending the raw materials, branches all over, and depots. That needs to be taken care of. This is what we are looking to get. It's a process flow diagram that has been given, how work comes and start working around it. Similarly, for the flow of goods, how do we go around it? Step 1 and step 16. You will look at it, how exactly that things can be going around. Let's say step 1 is identifying product, marketing. Step 2 is preparing a project brief. Step 3 is obtaining management approval. 4 is determining the customer need. 5 is performing competitive analysis. 6 is developing the business or platform strategy. Seventh is to develop the product. Remember, the seventh can be done either from fourth or from sixth, or even from either from fourth or sixth. Remember, that's it. But in between the relationship between fourth and fifth, you can have a competitive analysis. This is optional completely. Step number 5 is optional. You need to understand what competitors are doing. You may ignore it altogether. So that is what needs to be understood. Similarly, for developing of the product concept, we can go to step number 9 or step number 12. From step number 8 to 9, it can be developing operational strategies, evaluating and probably conducting the things. Or step number 8, we can start developing the preliminary cost estimate, prepare the project risk and management plan, prepare the business case, and come to this step number 16. Or possibly we have another two step, another way is to prepare periodic roadmap, conduct the concepts, and that is all about it. This is what we are looking for. So please understand, process flow diagram gives you an eye opener which route to follow altogether. Scattered diagram is something which is very simple, very easy to understand. It is basically the representations of what exactly is happening in real world time. And if you have to plot the processes, you see it can be equally plotted out here. That means there are no pressure points, there are not no conjunction, there are no delays. But in this particular thing of wine being consumed and heart disease being taken care into rotation, you see there is a clusters out here which is missing out here, so it is not uniform. That means if you are increasing the heart deaths, why is it increasing if you are consuming or not so consuming wine per se? So this clusters will give us an idea, a fair bit of an idea what goes around it. I'll give you a host of example of clusters of scattered diagram. Look, this is a negative correlation, absolutely negative correlation, which says so. Absolutely doesn't go. The more the number of wine that we were drinking, the cases of heart attack was on a lesser side. but that need not be the cases. Weak negative correlation is something which comes around here. This is a very strong thing, but this is very scattered. So might not be any correlation or a weak correlation. Look out here, it is scattered throughout. So there are no correlation. Weak positive correlation, when you look, there is a conjunction that comes around it, and a strong correlation, which are absolutely on a horizontal line. Probably they have been scattered around it. So yes, so positive and linear, negative and non-linear, and no relationship, which is absolutely further engage upon it. With this, we need to understand how well we are performing. We come to the control charts. Control chart is where we say the upper control limit or the lower circuit limit, whatever which comes around it, the upper circuit or the lower circuit with 9.25, upper circuit with 10.86, and in between is your process. The process can fluctuate. Every time it crosses a buffer stop, you need to take into consideration the center line is around 10.058. This is what we should be planning for it. This is what we should be looking ahead in our times. With this, I come to an end of this presentations about the various methods and tools of total quality management. We have spoken about the flowchart, Ishikawa. We have spoken about the scatter diagram. Everything has been understood and detailedly discussed. Thank you for watching this video once again.